Welcome back everybody to linuxacademy.com. My name is Terry, and in today's video we are going to talk about the Nginx HTTP web server. Specifically, we're going to begin our exploration of the Nginx HTTP web server, why it's important, how we can use it, and why it's different from the other HTTP web servers that are around. So Nginx has actually been around for some time, but it's only recently begun to pick up traction against the king of the hill, which, as we all know, is the Apache HTTP web server. Apache is currently the king of the hill. Depending on the estimate source, Apache has anywhere between 55 and 75% of web server traffic as far as what it's serving on Linux or Unix or Windows operating systems. That Apache is king of the hill, why is Nginx beginning to gain traction in terms of the traffic that it serves for web connectivity? So let's go ahead and take a look at what Nginx is and why that may be. So what is Nginx exactly? Well, let's go to the source, and according to Wikipedia, Nginx is an open source reverse proxy server for HTTP, HTTPS, SMTP, POP3 and IMAP protocols, as well as a load balancer, HTTP cache, and a web server. So that sounds like a lot. How's it different from Apache? Well, Apache can do a number of those things. However, Nginx does a number of those things slightly differently or slightly better depending on its use. So mainly, from an architectural standpoint, Nginx differs in how it handles requests. So Apache's HTTP server defaults to the model of request handling is a threaded or process-oriented approach. It generates threads for each connection and then attempts to do as much of that processing in parallel. And that has both advantages and disadvantages. One of the disadvantages is that for static content, it gets multiple contents of multiple copies of files, and it can take up additional memory space, particularly in how it manages sessions. What Nginx does is, instead of taking that approach, they use an asynchronous event-driven handler for requests, which means that although the connections come in and are treated independently, they can share memory space. So it allows Nginx to more accurately provide predictable performance under very high loads. And in fact, that's one of the main reasons that Nginx has begun to gain traction versus Apache. Whereas Apache, you can serve concurrently in a relatively large Linux system, several hundred connections in parallel, depending on what you're doing, depending on the memory space or the modules that you've incorporated. Nginx can, in a very small memory footprint, serve thousands and thousands of concurrent connections while still maintaining keep alives or session states. What does Nginx feature? Well, it features a whole bunch of stuff. So it handles static files, index files, and auto-indexing, nothing different there. Serves as a reverse proxy with caching abilities, whereas Apache, you can use it as a reverse proxy, but you have to add modules or additional functionality like Varnish for it to maintain caching ability. Load balancing of nodes, and again, Apache will work with load balancers, but you have to put something in front of it to do load balancing, whereas in Nginx it's built in. It supports fault tolerance, so you can configure multiple nodes in an Nginx web farm to share session state in memory across those web servers, whereas with Apache, you don't have that ability. OpenSSL support for certificates, including SNI and OCSP, which with the recent Heartbeat bug, as well as the OpenSSL problems that have been exposed from a security perspective lately, is important, because that security transport layer is constantly under attack by hackers. So including support for the latest and greatest encryption technologies is important. Fast CGI, PHP, FPM, and SCGI support. Those are just modules in how it handles executable files for authentication and website application development. It's fully IPv6 compatible. Apache is IPv6 compatible, but it's a module edition, and it works much better in 2.4 than it does in 2.2. Whereas with Nginx, from the get-go, IPv6 has been a part of the consideration during its development. WebSockets and HTTP 1.1. live stream file compression, and it isn't just from a gzip perspective for files or images. It also does a very good job of live stream compressing video content. URL redirects and rewriting. It handles bandwidth throttling, which is again something that you can do through Apache through third-party modules, but with Nginx we'll talk about how we can do bandwidth throttling on our local configuration. One of the more impressive modules that is built into Nginx is geolocation of IPs. So you can manage and view IPs based on where they are. So it lends itself particularly for CDNs that are serving static content. And if you don't know what a CDN is, it's basically a collection of web nodes that serve content based on where you're located, so that your content is coming from a server in an IP that is geographically closest to where you are. And as we mentioned earlier, it has a very low memory footprint. So for example, it can serve more than 10,000 concurrent connections with only just about 2.5 megabytes, and not gigabytes, of memory in use for those keep alive sessions. So that's very important, because the lower the memory footprint for the overall solution is, the more concurrency that you can get. So why is it sometimes referred to as the next generation of web services? So as we know, Apache is currently the king of web servers, but Nginx is making its mark, and that's why we're here today. As the ubiquity of web continues to extend its reach into every facet of our lives, performance becomes paramount as concurrency increases. So as every device that we use in our lives, from our monitors, which are typically not connected, but now our TVs are, our headphones, our watches, our smartphones, our keyboards, our mice, as the Internet of Things becomes more and more important in our lives, those number of connections that use web services are going to begin to overrun the ability for web server farms to function and provide that content. So Nginx is going to be important as the Internet of Things becomes more important in our daily lives, as it pushes the performance envelope in terms of concurrency and response time. So over the course of the next several dozen videos, we're going to look at how to install and use Nginx, as well as how to take advantage of all of the features, particularly when it comes to performance and concurrency. That's all there is to it. My name is Terry for Linux Academy.